Right, we're going to go through a quick example on the different relationships in MSP. At this point, I've assumed we understand how to construct a work breakdown structure, and I'm going to show you by default how most people set up a WBS. So on here I've got a very quick example of painting a room with 4 walls, and you can see here I've just combined the durations of each wall into a total. So here under cut in, 60 minutes, 4 walls, that's 15 minutes per wall. Paint, 80 minutes, that's 20 minutes per wall. Most of the times we just combine those together, and I'll show you the disadvantages of doing that in a minute. Now I'm just going to add in some logic and add in the predecessors, so I'm just linking these, and you can see it's a series relationship here. What you'll end up with is a schedule that looks something like this. You can see here our finish time is around 3 p.m. Okay, now we've got our work breakdown structure. Alright, so I'm just going to change how these are displayed into minutes just to help me out. I've just done it quickly, but if you go File, Options, Schedule, and just change that from days to minutes and you're good. Okay. And now we can see that our project is going to take us 180 minutes for this stage, 140, so on. We can quickly put a task here to work out a summary. Okay. And all we need to do is just move these quickly to show us that our whole project will take us 370 minutes to complete. I'm going to delete that. So we're dealing with 370 minutes to complete the whole project. This is based in a series relationship. It assumes, firstly, a finish to start relationship. This task must finish, allowing this one to start, and that trickles on the domino effect. The whole point of scheduling efficiency is to try and run tasks concurrently. So running tasks in parallel enables you to get the project done quicker without compromising on quality, which is usually the trade-off. So there are two dependencies on your ability to do this within your project and your specific task. Number one is logic. So is it possible for me to paint the walls before I start cleaning them? Probably not. Okay, so some tasks say this task needs to be finished, allows another one to start. The other one is resources. So you may not have sufficient resources to do everything all at once. In terms of scheduling a project, ignore resource constraints for now and just focus on logic constraints. I'm just going to jump over to the whiteboard, just explain a concept. There are 4 main relationship types in Microsoft Project. The first one and the default one is the finish to start relationship. So you have a task, task A, and finish to start says as soon as task A has been finished, that will enable task B to start. By default, if you don't change anything, that's what Microsoft Project will use to schedule all your activities. Think about the duration for a second. If task A takes 5 days, task B takes 10 days, the sum of that is going to equal 15 days. It's the least efficient of the relationships, but sometimes logic says there's no other way to do it. Another type of relationship is a start to start relationship, which suggests that as soon as task A is started, task B can also start. If you think about the logic here, if task A takes 5 days and task B takes 10 days, using this relationship, this whole activity is only going to take 10 days, depending on task B. So you can see just by changing the relationship here we've saved some time, but it may not be practical. That relationship type may not work for this. The third relationship is a finish to finish relationship, which again suggests that task B can finish dependent on the finish of task A. And what I'll do is I'll go through some examples of each type. Similar model for this, we would also get 10 days for this relationship. A is 5, B is 10. The last type of relationship is a start to finish relationship, which is just pretty much the inverse of this. In this case, it says that task A can't finish until task B starts. So effectively, if you're working on task A and task B turns up late, you need to keep going. In the finish to start relationship, you would have a similar sum of calculation there. So the real relationships where time can be saved are the start to start and finish to finish relationships. If you don't tell MS Project otherwise and use a high-level work breakdown structure, like we've done, I'm just going to grab the paint category here. We've assumed that, yeah, there's 4 walls and it's going to take us, let's just focus on paint, it's going to take us 80 minutes to paint those 4 walls. What Project's done is it said, okay, well, what's going to happen is wall 1, wall 2, wall 3, wall 4. And the sum of those is going to be 80 minutes because 20, 20, and so on. Right. As you can see from the last explanation, it's assuming that finish to start relationship. The first question in this example is, do we need to even have a relationship between the tasks? Another way of doing this is saying, okay, well, what happens if someone paints wall 1 at the same time, someone's doing 2 and someone else is doing 3 and 4? Again, as I previously noted, this depends on us having the available resources. If time is critical, hey, maybe we can make those resources available. Using this approach here, where the tasks, there's no actual relationship between them, I mean, by default you can say it's a start-to-start relationship. The whole activity here would take us 20 minutes. Just by adopting this, we've actually saved 60 minutes or an hour from this project, which is a good time saving. Translate that to days or months, and you can see the larger scale effects on a project. Right, back to MS Project, and I'm going to show you how this can be practically applied to the software. What I've done behind the scenes, I've gone through and detailed this component of the work breakdown structure, which we're focusing on in the previous example. And I've gone paint wall 1, 2, 3, 4. I've also added in the linking here, which we would have had anyway because it's a series relationship. So even if I hadn't done that, all we would have seen was this as one big task. So applying the logic we talked about, if these don't need to be linked together, all I'm going to do is remove these relationships, and now the task can be concurrent. And that shows us that the paint task has gone from 80 minutes to 20 minutes, giving us that hour saving that we discussed previously. Given the benefits that we achieved by detailing the paint task, I'm going to apply the same level of detail to the rest of the tasks, where I can identify a relationship that may exist that's better than the default finish to start. So if it's obvious that there's no other way I can do it, I'm going to leave it at high level. But if I can find some efficiencies within a task, I'm going to break it down further. Okay, we're back, and as I said, I was looking for efficiencies within each task, and in some cases I have drilled down the work breakdown structure, such as clean the walls. I've broken that into each wall, and where this was 20 minutes initially, I said, well, 5 minutes per wall, and done. Patch the wall, broken that down, tape the wall, paint, that's cutting in, and that was 60 minutes. I've broken down to each wall is going to be 15 minutes. Paint we did earlier on, remove the tape, done, and the rest I couldn't find any efficiencies, so I left them at high level. When we start rolling those up, you can see what it's actually done. Is it's actually reduced our total project's duration substantially. I think prior to this we're running at 370 minutes, and if we just quickly insert a task here, we can see the duration of these is now 115 minutes. So we've gone from 370 minutes to 115 minutes, giving us a saving of 255 minutes. Okay, now what I'm going to do is I'm going to try and apply the scheduling logic, and this is going to differ on how you want to run your project. So for my intuition, I'm going to say that my project, I need to start off with cleaning. Once cleaning's been done, patching can occur, and I guess taping can also occur here once cleaning's been done, because we don't need to wait for patching. Once these two have been completed, then we can start painting, which is the cutting in, then the roller. Once the painting's been done, we can remove the tape. We can also wash the equipment. Once it's been washed, it can be stored. And I guess our last task here is the inspect task, which would require the tape to be removed. And that's it, I guess. The client doesn't really care about whether the equipment's washed, so we'll just link it to there. Alright, so I'm going to make this kind of pretty and just explain to you how you can link all these things to give you a bit of a schedule. So one way of doing it is by linking these categories that we've done here. So we're saying clean occurs first, no predecessors as per here. Patching requires cleaning, so we've linked that with the 2. Taping, I'm going to change this to reflect what we've discussed. That patching no longer needs to be done, as long as it's clean. These can happen concurrently. Then we go to the paint aspect. Cutting in, we've said that as long as this is our cutting in, patching and taping are done, then we can start that. So I'm going to put a 7 here to represent the patch, and I'm going to put a 12 to represent the taping. Okay. For the roller, we really need all the cutting in to be done, so I'm going to put 18 here. I think I've just replaced what was already there. Once that's done, we can look to remove tape, and we've decided that once it's painted, we can remove the tape. That's fine, I'll leave 23 there. Wash equipment, we've said look, the tape doesn't need to be removed. That can be done as soon as the painting's finished. So I'm going to put 18 there. Store equipment happens there. Inspect, I'm going to say as soon as the tape's removed, then we can start inspection. So I'll put that as 23. And client sign off, well, I guess once it's been inspected, we can sign that off. We might want to integrate some other tasks there to make sure the equipment goes away, and put some linking in project finish and bring all that together. But at this point, we can look at our project. What I'm going to do is close the whiteboard, and we can see here very quickly what our project's going to look like. Okay. That's using the logic that we applied. If we quickly insert another task here like we did before, just to get a gauge of how long this is going to take us. Okay. Indented everything here. Using this method, linking everything in together like such, our project is only going to take us 80 minutes. So we've made a further saving. And the saving here was really achieved by running the cleaning and the taping, the patching. And the saving here was really achieved by running the patching and the taping concurrently, as well as negating the cleaning of equipment to be done prior to the client inspection. For me, that makes sense. We can actually do this and create some real savings in our project. So when the client comes to us, how long till I can inspect and sign off on it? Instead of previously saying 370 minutes, we're now going to say, well, give me an hour and 20 minutes and I'll have it done ready for you to inspect. I'm just going to quickly label this task painting, because I keep bringing it up, so I may as well just have a constant task there. And that shows us the whole works programs associated with painting. So we've got some great time savings from just doing some simple scheduling, and we still really haven't changed any of the scheduling relationships from one task to another. What I'm saying there is that every time we've scheduled something, we've just used the default. We've assumed the finish to start relationship. So this is going to take a little bit of time. What we're going to try and do is identify another type of relationship we can use. And if you think about a lot of these things, we might be able to try another type of relationship, maybe the start to start relationship. So do we need to finish cleaning the whole wall until we can start patching it? Again, this goes down to how you want to run your project. If I was painting a room, I might say, look, I'll do all the cleaning, then I'll start patching once it's done. But really, to save time, you could start cleaning and wait a minute or so, and then you could start patching the cleaned areas from then on. One thing I haven't talked about at all is lag, and we'll bring this in right at the end of the session, so just stay tuned for that. So my logic here is I'm going to say that it takes 5 minutes to clean a wall, and it takes 1 minute for drying to occur. So effectively we need to wait 1 minute before we can start patching. Okay. So what I'm going to do here is, for this relationship here, I'm just going to delete this one here, and I'm just going to say to patch wall 1 we need to have cleaned wall 1. Okay. And if I just press enter here, it's just going to assume a finish to start relationship. So I'm going to tell it otherwise. I can do this a number of ways. I can go here, predecessors. I can change the relationship here. I'm going to use the start to start for an example. Press that, press OK. And what this has done here is just said, okay, well, once you started that one, you can then start that activity. That might be fine. But as I said before, we might have to wait a certain amount of time. So I'm going to add what we call lag. I'm just going to double click back on here. And here I'm going to add 1 minute of lag. These are normally set as a default to days, but given the nature of the project, I change everything to minutes. I'm going to press OK. You can see this activity here starts. That's clean wall 1, and then after a minute we can start patching wall 1. If you wanted to do this another way, you could, instead of using this screen, you could just do the shorthand. You could go, it needs task 4 to be as a predecessor. I'm going to put the relationship as start to start, and I'm going to add 1 minute of lag, and project understands that as a shorthand. If you don't want to memorize stuff, just double click here, head to the predecessors tab, and use these controls here. You'll get the same effect. So I've just gone through and copied that across, had the same sort of logic. Patch wall number 2 requires us to clean wall number 2 plus that minute of lag we identified. And I can keep going through. And what I'm doing here is I'm following our network diagram that we very quickly did, where we said we need to clean, we need to patch, we also can tape at the same time we're patching. Once those activities are done, we cut in, we roller, and so on. So what I can do to save some time is for the taping, I can copy these relationships because they're going to be the same. So tape wall 1 requires us to start cleaning wall 1, we can wait for a minute, and then we can keep going. And the reason behind that is that, you know, we've cleaned the area that we're going to tape, so it's free of dust and so on, then we can start taping. That's fine. Looking at our project's duration after doing these activities, we would actually expect the project's duration to have increased, because at the end of the day we've actually added in 8 minutes of extra time or waiting time that needs to occur. But if you look at the project's duration, it's actually gone down from 80 minutes to 76 minutes. But I'm stumped at the moment. Why, when I've added all this extra waiting time, has my project's duration actually decreased? Think about that for a second. Okay, how'd you go with the answer for that challenge? Why has our project's duration gone down from 80 minutes to 76 minutes, even though we've added 8 extra minutes of lag? Simple. It's because we've actually used the start to start relationship rather than the finish to start relationship on those activities. Previously we had this logic that we have clean. Once clean's finished, then the patching can occur and the taping. That was our original configuration. What we've done is we've actually brought these activities here and said, look, you don't need to wait for this activity to finish before you can start these. As soon as this one starts, we wait a minute, which we called our lag, then these can start. And so our time saving has been because we've actually managed to bring these forward, regardless of the extra time we've added on. To find the 4 minutes, the cleaning stage was 5 minutes, so if you look, time equals 0 at the start of this activity, time equals 5 at the end. What we've done is we've reduced 4 minutes by saying that patching and taping can occur after minute 1. Okay. So effectively, it's saved us that 4 minutes here, because now everything can start at time equals 1 rather than time equals 5, giving us that 4 minute saving. Okay, here's a question that sometimes gets raised when you've actually come to the site. And initially we identified in our very messy now network diagram that we need to clean, patch, tape, then we can start cutting in. What if you actually identify on the site that in order to cut in, patching wasn't necessary? So for example, there were no holes or any issues towards the borders of any of the walls. All the issues were in the middle. Then you might say, okay, well hang on, we don't actually need to patch before we start cutting in. we still need to patch before we start rollering. So what I'm going to show you now is just a way to save some more time. So we've identified the site, we've looked at it, and we said, okay, well hang on, we don't need to patch, we can just start cutting in. So here I've represented it like this. So for cut in, I've said, okay, well all we need to do now is to tape it, and I've added 2 minutes of lag. So let's assume you've got two resources, one taping, the other one painting. We'll give the person taping a 2-minute head start just so we don't get in their way. If you look at the maths, we shouldn't catch them because this takes 15 minutes versus taping takes 10 minutes. So when you're looking at your head starts to give your lead time, look at those two and see which activity actually happens quicker. If the taping actually was a slower activity, so it took longer, we might leave a longer lead time so we didn't end up catching that other resource. But what I want to do is I want to make sure all the patching's done before I start doing any painting on the roller, because once I get started it's pretty quick. So I'm going to show you very quickly how to add another constraint in here, another predecessor. Easiest way is if you've got this information here, double click, you'll open this pane here, and all I'm going to do is add another line. And here I'm looking at painting wall 1, so I want patch wall 1 to be a predecessor. I'm going to put 9 in here, and I'm just going to let it do its own thing. You could put lag in here if you had something to wait to dry, but I'm just going to assume it's 0, and I'm going to press OK. Same thing, I'm going to go through and repeat these exercises. In the interest of showing you how to do it shorthand as well, you can put a comma in, put the next one through, and you can see what's going on now. We're getting two links, one from the activity here and one from the activity up there, which was our patching. Okay. Choose how I do it, whether I want to double click and put an 11 in there, or put a comma and put a 12 in there. Either way, it's achieving the same thing. Okay, to round it up, the next thing we're going to do to save some time is in the tape removal. And we've just made a judgment call here. We've just made a decision that we're not going to wait to finish painting to remove the tape. All we're going to do is wait until the wall's been cut in, then we can move the tape respective for that wall. I mean, it's a high risk maneuver, but in the interest of saving time, that's what we're going to commit ourselves to. So, what I'm going to do here is I'm going to say that once I've started cutting in, I can start removing the tape. What we do have to be careful of is the duration for this task is only 5 minutes, where its predecessor is 15 minutes. So in terms of leaving some head start or lead time, we're going to have to be quite careful of that, because we want to make sure that we're not held up by the preceding task. In this case, I'm going to allow 9 minutes of lag between when we start cutting in to when we start removing the tape. Okay. To do this, double click here, and we're going to put the ID here as 20, okay. And I'm going to put in our assumed 9 minutes of lag. Make sure you change this, because if we leave it as finish to start, it's going to wait till the activity finishes, then add on 9 minutes, which is not what we want to do. We want to say once it's started, wait 9 minutes, and then we'll start taking the tape off. And our relationship will look like this. I'm going to go ahead and fill this out for the rest of them. So once it's been done, you can see our remove tape here, and we've said that we don't need that to do the client sign off. I find it's best to link everything together, so have no dangling tasks, so say project finish, give that a milestone, and then what we can do is we can link all these dangling tasks to that. So we can put in 30 there, which links all those tasks, and we can also put in any other task IDs there that we want as a predecessor. Okay. In this case, I am just going to put a comma, and I'm going to put the client sign off, because I think everything else is linked to that. We can go through and double check that anyway. Okay. Client sign off, instead of 25 there, that should be 38. And this is actually one cautionary note. I've left this as a default for manual scheduled. If you have things as manually scheduled, just be careful, because it won't change if you do update your schedule. So I've done a really cool video on how to change things from manual to auto. In this instance, I'm just going to change this, but have a look at the video because that will help you out. And you can see here our project duration now is 61 minutes. Okay. So we've done a couple of things and we've saved a lot of time in our project. I think we start off at 370 minutes, now we've gone to 61 minutes, and in some cases we've taken a few things which may compromise quality, but we didn't need to. Just by changing the relationships and how things were scheduled, we actually find that we can save a lot of time in our projects.